Good morning, everyone. Today I'm teaching hypothesis testing, a fundamental tool for all data science and statistics. So, what is hypothesis testing? Hypothesis testing is a tool that we use to determine whether data supports our guesses or hypotheses about how the world works. To explore hypothesis testing in more detail, let us begin with a simple example. Imagine that as you stroll along the pristine beaches of San Diego and La Jolla, you spot a shiny quarter glinting in the sun. With a sense of curiosity, you pick it up, and as you continue your walk, you flip the coin through the salty breeze, noting each time it lands on heads or tails. After 100 flip of the coin lands on heads 63 times and tails 37 times. Having the coin land on heads so many more times than tails, most people would be convinced the coin has to be an unfair coin. But at this point in time, there are two distinct conclusions that we can draw from this experiment. First, the coin could be a fair coin, and just due to chance, it so happened to land on heads 63 times. But two, the coin is biased and is favored to land on heads more often. But how can we know which of these two conclusions are more likely? For that, we have to use hypothesis testing. There are four main steps to hypothesis testing. First, we decide on a null and alternate hypothesis. After that, we determine the test statistic. Thirdly, after we both have the null hypothesis and our test statistic, we generate an empirical distribution of test statistics under the null hypothesis. And lastly, after we both have the empirical distribution and the observed test statistic, we determine whether it's more likely that the observed test statistic occurred under the empirical distribution using p-values. So, what is the null hypothesis? The null hypothesis is the statement that we want to disprove. In our example, it would be that the coin that we found is a fair coin. This is our null hypothesis because during our experiment, the coin flipped on heads 63 times and on tails only 37 times. The alternate hypothesis, on the other hand, is a statement that we want to prove, which is that the coin is biased and more likely to land on heads. After we have the null hypothesis, we determine the test statistic. What is it? The test statistic is a number that can be calculated from sample data. For example, in this case, the test statistic can be the number of heads the number of heads that we observe when flipping a coin 100 times. The observed test statistic for this case would be 63 heads that we saw. After we have determined the null hypothesis and test statistic, we generate an empirical distribution. An empirical distribution in data science is generally generated using computer simulations. Like in this example, I simulated the flipping of 100 fair coins a million times. So in total, the computer flipped about 100 million coins to get this distribution. After we have our observed test statistic and the empirical distribution, can we determine whether the coin is fair or unfair? No. We have to decide beforehand what probability, the significance level, to reject the null hypothesis, to say the coin is not a fair coin. 5% is the typical significance level that is used, and that is what I'm using. We have to also find the p-value, or finding the probability of observing the observed test statistic or test statistics higher than the observed test statistic in the empirical distribution. The area highlighted in red in the graph, in the histogram, is the values that we're trying to find. The p-value for flipping heads 63 times or higher is 0.6104%, and with a significance level of 5%, we reject the null hypothesis and determine that the coin is not a fair coin.